Excuse me. All right. So second talk, same as the first. Oh well. If you printed handouts, find one that matches this. Again, that's who I am. If you send samples to our lab, probably the first point of contact would be your local extension office. So, or maybe more different, that people send samples and deal directly often with the lab, but the local office can do a lot, but we're only one piece of the entire thing. Like the plant clinic, I think you have to work through the local office, so it's good to get to know them. That's where you can get our soil sample box containers or boxes. If you do want to contact the lab's phone here ending in 6893. I may check that. More than one person may check that message. Chances are, though, who you'd be communicating with is Courtney, who you just heard from. Otherwise, there's my desk phone ending in 9807. So well, soil testing, it's used to estimate nutrient availability in the soil. So the end goal in mind is to provide fertilizer and lime recommendations. So now most states have a government lab. Most are with a land grant university, such as here at Virginia Tech is where Virginia Popular Extension's lab is. North Carolina, it's part of the with their Department of Ag right there in Raleigh, though, where NC State is. And there are plenty of private laboratories, which you'll definitely want to get into towards the end of this talk. So pretty much all of them are going to have a test that's a package of tests. So that answers the basic soil fertility questions, so you can provide those recommendations. Ours is called the routine test. We do it routinely on pretty much all the samples. It involves a couple of pHs and determining the plant available levels of 9 elements, and we provide an estimated CEC. Early on in modern soil testing history, it was mainly an educational tool promoting the benefits of lime and fertilizer. So now today, it's also used to help manage environmental risk. I break down the process of soil testing into 4 steps. So first, one needs a sample to test. As with other testing, there is a set protocol to the sampling so that results can be interpreted. You need to go get a blood test. They're going to probably want to know, are you fasting or not, so they can interpret like the glucose level. So then there's the analysis part, where think of a lab generating the numbers. And then once you have the numbers, then one wonders, what does it mean? You want interpretation, what to do about it, if anything. Sampling instructions. So that's the first part. Got to get the sample. Sampling instructions are summarized in our soil sample box and our lawn and garden form. And I think I heard Courtney mention our lab's website. That is something, I could not get this URL again, but try to be good to memorize. It's just soiltest.vt as in Virginia Tech.edu as in educational. So it's got a lot of links, a lot of things, answers. Things could be answered there. So it contains more detailed sampling instructions, all the forms, the other soil test notes that the reports refer to for additional information. And it's got example reports or lab procedures, things like that. So the greatest potential for error in soil testing is taking the sample. It's not necessarily easy to get a representative sample. My lab stores samples for a while after analysis, because if the lab has to rerun a sample, then we prefer to rerun the original sample due to sampling variations. Each sample weighing only a pound or less can represent millions of pounds of soil in the field. One sample should represent just one management unit. If an area has been fertilized or limed differently in the past, then it's best to sample them separately. Separate fields into uniform areas no larger than 10 acres. So the first task is to decide on your sampling areas from which you send the lab one sample per area. It's best to sample different soil types separately. I've used the word best a couple of times here already. I mean, there's the ideal, and there's often that hits the practical world. So, but indicators of different soils would be different landscape positions, usually different topography. You heard Dr. Galbraith yesterday probably mentioned the cantina, different color probably goes with different landscape position. The texture will probably change, especially if it's have an eroded area, probably have different texture and color. But as the first task, what is your sampling area? So, sorry, I'm already drying out. So, take separate samples from areas that differ significantly if they can and will be managed as different management units. I mean, if you're not going to manage them, like I can't treat them different. They're all going to be treated the same. Then I guess you can just take one. If it's less than 10 acres, one composite sample of all that. So, but you want to avoid odd spots, avoid old fence rows, ditches, dead furrows, and other spots that are not representative of the entire field. So there's field variability due to natural and man-made causes. Is there more grazing or manure applied in one area? There's different tillage used. Sample odd spots separately, or if they're small enough, just avoid them altogether. One needs some type of sampling tool, a clean plastic container. Say plastic in order to avoid micronutrient contamination. So it doesn't take much to make a big contamination. So, and I got an old picture here, so don't use a metal bucket. I would also forget the coat and tie. And get the sample containers from the lab you plan to send the sample to. That will ensure that you save the required volume. You don't want to have to go back out and resample. Common sampling tools are the auger, spade, shovel, trowel, if I can pronounce things, and the tube. And in the lower left, it looks like a hydraulic sampler. That may be handy for this time of year. Continue to take additional subsamples from the sampling area. How many? Well, for a 4-acre field, multiply 4 times 5, which equals 20 subsamples. Now, by mixing those subsamples together, you create the composite sample that will be sent to the laboratory. But, generally, the less tillage there is, it'd be nice to lean towards taking even more cores, just to get, because you're not mixing things up, homogenizing things as much. So no-till, more would be even better. So in what fashion or pattern do you take subsamples within the area? Normally in a pseudo-random manner, such as a zigzag pattern to minimize the variability that may be present in your sampling area. This allows you to obtain a reasonably representative sample. Maybe not be truly random, but it's, again, ideal, but it's practical. You want a continuous line you're walking across the field. Now, sometimes a grid or systematic pattern is used, especially when GPS equipment is involved. So now the sample what depth? That's important. Consistent depth. That's where, like, it's too dry. Hopefully you're going out there sampling when the soil is not either too wet or too dry. But you normally sample to plow depth. Now, no-till situations, 2 to 4 inch depth, or like if you're doing just turf, most grass roots are in that top 4 inches, so 2 to 4 inches. So one needs to mix the cores thoroughly, again, in a clean plastic pail. So it's best to sample when the soil, repeat myself, isn't too wet or too dry. Too wet, you're just making a mud slurry. Too dry, if you use that soil probe, that hydraulic push behind it, It's hard to get in. That could be one thing. Sampling variability. You go out, you hit an odd spot, or you went out like this past December. It's dry, it's cold. You hardly go down 2 inches. You go down. We just had a lot of rain. All of a sudden, that probe's going down several more inches. Well, you're going to get different results because you're not sampling the same consistent depth. So, and then fill the lab sample container or to whatever indicated level of fullness indicated on that sample container you have from the lab you plan to send things to. So, sample between rows. All fields should be tested at least once every 3 years. That's especially a nutrient management plan. I think that's stipulated. Now, do not wait until the last minute, please. Fall is a good time to sample. Why fall sampling? Well, labs are the busiest right before planting. Depends on the weather, but for this lab's busiest post-harvest to pre-plant to planting time. And actually, this last December, colder, drier, probably we were significantly lower sample volume than the year before. So that could mean I've seen a bad year, came in early, came in late, and just pretty much, it's a tidal wave of samples coming into a lab. So, and people tend to procrastinate. So, and everyone's in a hurry, right? At the end of March. So, another really good point. What if you need lime? I think probably a repeat to talks is the critical keeping the pH in the right range. And there's usually no quick fix to adjusting the pH. Farmers are usually good at keeping it in a good range. Homeowners, not so much. Gardens, you see a bimodal curve where they've never added lime, or they add it every year. Too much, too little. Neither's not good. But ag lime, slow reacting, especially again if you no-till situation, you're just throwing it out on the surface. So lime reaction time. So if you need lime, it's good to know in the fall if you can get that lime out before winter sets in. And then you got other wetting and drying cycles, maybe even freezing and thawing creates some cracks in the soil, maybe even help work that lime down into the soil. Again, if it's a no-till situation, that would be good. So again, beat the rush and the lime reaction time. So test results and recommendations are only as good as the sample collected and information provided. Now, I mean, what's wrong with this picture here? He's using a proper tool. He's got the sample container. Well, there's probably no sampling of the inner part of the field. Therefore, the sample will not be representative. Now, edges of the field are not going to be representative, especially along a limestone gravel road. It looks like the subsample is going straight into the lab sample container, which won't hold enough subsamples to get a representative sample. One reason you need that bucket is if you take enough cores, subsamples, you're going to have more than fits in what you want sent to the lab. So, and then when you want to break it up, if there's any thatch, especially like turf, throw that top thatch away, any coarse fragments, stones, twigs, get rid of that, break it up by hand. You don't have to totally smash it, but break it up, mix it up, thoroughly homogenize it, then fill up the lab's container. So, okay, other questionable things about this method pictured here is a consistent, correct depth being taken. So it depends how much he leans out of the vehicle, I guess. So point is, sampling is labor intensive, and this may save time, but don't resort to this. Remember, garbage in, garbage out. So the soil test report could end up being misleading then. There are times to be getting a sip of water. Okay, the last step to sampling is to fill out the sample information sheet. Now, all 5 of our forms are available online, and so they're going to be the most current version. We've gotten in forms that are not saying years, but how many decades old is that form? So now writable means that One can fill in the form before you're printing. This is especially handy for repeated information, like name, email address section. Reports really are only going by email now. So you can type that all in, just print out the front. We know what the back looks like, so you don't need to print that. Oh, yeah, if you print it out from earlier slides, I just sort of more recently threw in this slide. We've been working for a long time now on a new LIMS, the Laboratory Information Management System. By this time next year, I would say we will have switched to this. So just giving you a heads up warning. It says University of Tennessee, we've been working together with them on this new system. I think I threw in one more slide, hit that. Okay, here. Look, of these listed factors considered, they're considered in the software to generate the fertilizer recommendations. I mean, how many does the lab come up with here? It's only the soil test levels. All the others need to be provided to the lab. Hence the importance of filling out the soil sample information sheet. The more and better the information provided, the better the recommendation is given back to you. So my workers are good, but they're not mind readers. All right, sort of go through the most used form is the commercial crop production form. Say 70% of our samples come in with this form associated with them. So we need, where to send reports to. We can send a secondary email to somebody else. Extension agents, well, if you're a nutrient management plan writer, you can get them to put that on there. An extension agent can always look up a report, so they don't need to be on there. See, let me grab hook up my mouse. Hopefully you can see my cursor. So this line, county where soil is located, required. That's not where the grower, the grower is the farmer's living. His mailing address is where's the soil. I mean, we have some, border the Virginia, North Carolina. So we know where's that, and that's to interpret the soil map units down the bottom half. You got sample ID. That's what you want to do on the box. We got, it takes a lot of time, set matchup, setting them up. We got to match up the sample information with the soil. That's critical. A human does that. 5 characters is most you could probably remember, match up in your mind at once. So that is what you write on the sample container. This is for additional spots. I'll jump ahead. Our new system will give you a slew more of things. You can put GPS, latitude, longitude coordinates in. You can put a lot more, gives you a lot more room, sample identifiers, field identifiers, farm identifiers that you can put in. So, and once you're, I'll get into it later, I guess. The new system, once you put it in there, it's there. You don't have to keep putting it in like on a form or. All right. Now, if you want recommendations, you got to fill out crop to be grown, and you got to select the recommendation part is all done computerized. So you have to pick a plant code, and the new system will be more the name. The old crop code numbers will be in there. It's good to know the last crop grown. This really only applies, I put on here, if it's a legume. Otherwise, don't sweat it, And that's like alfalfa. If it's some legume, it can provide a nitrogen credit, and it's subtracted from the recommended nitrogen. And that nice, good thing. Keep jumping ahead, but we were ahead of schedule. So on the new reports, it will show what we would normally recommend, the amount of nitrogen. That could be some default, say it's corn. It may be productivity group 3, 1 being the highest, most productive soils in the county. And if you put soil series with the most productive on there, that will change. The crop expected yield, which will create, especially the nitrogen, it's like 1.1 pounds of elemental nitrogen per acre for corn. and then it'll calculate, and it'll show you how much. It'll say minus this for nitrogen credit for like a legume or cover crop, and and it'll then give you the recommended nitrogen. So it's sort of instead of calling up, well, why is this different? Oh, that's because you put the last crop as a legume on there. Okay. You let myself talk too much, but this is important. Last line application, instead of a slow reacting, that's why we want to know, we won't pick up if there's unreacted lime laying out in the field still. So it's good to know, if you know, when did you put it on and how much lime did you put on? And you'll also get a lime recommendation. I was just checking that out yesterday, that again, in the new reports, it would show a recommended amount minus this lime credit leaves you this much. And current reports, how come these two are different? And it's like, there's a lime credit on the one. All right, check is field as artificial drainage, some soil, horrible yields because wet roots, shallow water table, too red, but you had some drainage to the tiles to the field, all of a sudden, woo, the expected yield goes way up. So is a histosol, it's an organic soil. Now, not if you're growing organically. There's very few of these, more in North Carolina, but along the coast, you're probably going to find true organic soil. That changes the target pH. I'm not going to take time to explain it all. So I changed from organic. No, you're not asking if you're growing organically. Is the soil material classified? Official soil classification, histosol. So if you don't know what histosol is, you probably shouldn't be applying it. Check, are you planning to apply manure? Right now, that just flags refers to look to a soil test note on manure. All right, a nutrient management planner was happy. What did I say? Well, the software order of thinking here is if you have good yield data on a field, put that yield estimate here for the crop to be grown to determine the expected yield. I mean, you don't get more site specific than good yield data on the field, the exact field you're using. And I did end up making people select what unit because like tons per acre, you're cutting a hay field, it doesn't understand. We can't put in bales of hay, round bales, square bales. It doesn't understand. That can't handle it, put it that way. So you got to put it in tons per acre. Here's some explanation. What's an animal unit? Otherwise, it's still state legislators say, hey, we can't charge for the routine test if the sample's in state. Otherwise, you can select organic matter, soluble salts. Check and close. You can bill your business. Excuse me. All right, going to the new system. Big thing. You can pay online with a credit card. People have asked that for years. Sounds simple. That's been a headache getting. Well, I don't know if we're totally there yet, but that really complicated things. So, but you'll be able to pay by credit card on that. But if it's just a lot of these routine tests for farmers, and I mean doing that, again, check money order, payable treasurer, Virginia Tech. Okay, gonna flip to the back side. There's between all the forms, there's over 200 some crop codes, but here in categories, different kind of corn, and just get going faster. But here's some of the newer ones: hemp, hops. Down here, here's sort of explaining, what do we mean by good yield data? It's sort of on the bottom, the best average of best 3 years of 5. I'm not going to read it all. You can read it, but help. Where do you go? Maybe map units. Again, again, soiltest.vt.edu. You can go there. I got a link with sampling instructions to NRCS's soil maps online and things. So I also have links to outside, Virginia Tech or just the soil testing lab. And I think DCR stuff's got I see that a link to back to our website showing extension publications, for urban or vegetable production guides, a link to our page, linking to other useful extension guides. Okay. We're in time. Second most used form right now is oriented towards homeowners, home lawns, gardens, fruits, ornamentals. That's probably 20 to 25% of the samples we get in. They do have to pay. It's $10 a sample out of state. If Maryland doesn't have a lab, or DC, if the soil is out of state, the growers living out of state address, it's $16 a sample. Yeah, well, on the back, you've seen that in a nutshell. They're more novices, is how to take a good representative soil sample. All right, this is just another quick slide from the new website. It may get changed again. One good thing, all that's background soil information. Where's this field? What farm? Field identifying, the FSA, track and field number. And so you put it in there, it's in there. You go back to that farmer next year, it's still in there, but big thing I know DCR has been asking for, hasn't happened. Like, extension agents can go in, like the lab, and see all soil samples across the state. Like, well, who does a farmer want to share information with? Well, here they can control that. Don't ask the lab, go ask the grower. I'd like to see it, I need to, can I see your soil test reports? I don't know. Well, they can go on, log on to their account. That's one thing. That's different. You don't have now. You will go on to the system. I guess I'll put on soiltest.vt.edu. I'll make a link to go to this LIM system, and you'll set up an account and a password, and you'll have that. And it will all, the main thing is by the email. Now you can have secondary emails if you're a business associated with that account, but a farmer can go in here, like, what's this? Customers I have shared my reports with. So who have you sent? You've put in the system, I want to share my stuff with this person, with Steve Heckendorn. So, or my nutrient management planner, and it will send you an email that you click. Hey, they're saying this farmer wants to share their soil report to you, and then you respond to the email. Then you can log on and you could see their soil test reports. And then here's customers who have shared samples with me. You could see over here, hey, yeah, these are the farmers who have shared their sample with me. So it's a sneak peek preview of the new system. All right. Get synced here. Now, I almost said this earlier, but talking about wet or too dry, hopefully a nice moist soil is good to, after a good rain in a day or two. Today's more mild, maybe a good day to sample. What are you doing listening to this? So moist soil is okay. A damp or moist soils can be mailed to the lab, but if a sample is wet, soaking wet, we've literally had or poured water out at times out of the sample container. Then spread the soil ideally out onto paper, or at least leave the box open and let it air dry overnight. Main point is here, don't be tempted. Do not heat the sample by putting it into a conventional microwave oven. Maybe tempting, it's a lot quicker. Don't do it. Oven drying a sample can change results. Air drying samples before mailing can save on postage costs and processing time in the lab. But all right, quick quiz question here. So how can overheating change test results? More specifically, what nutrient can be affected? See if you're awake in the previous meeting. I'm actually going to pause here. Steph, if you're there in the chat box, or someone take the mic out, what nutrient can be affected if it's overheated?
This is our totally fine too. I won't mention who says it in the chat. Toss in a guess. You get brownie points for being brave.
what nutrient can be affected in the soil testing if it's overheated. Remember, they said there's maybe a lot of this nutrient in the soil, but only a very small percentage is going to be plant available.
Gonna give you a hint. It's not nitrogen because we don't test for that.
Yeah, and what right? Let's say that's
a freebie, guys.
Well,
I've got potassium and phosphorus.
all right. So it is potassium. That was in the previous talk. If you overheat it, some of those certain clay minerals, it depends on the soil. Clay minerals, 2-in-1 minerals, they sandwich, trap that potassium. They'll overheat them, they'll scroll back, and they'll release the potassium that could be available in a year or two, but not maybe this growing season. So potassium can be overheated. Here's one I'll answer for you, but I saw some sample questions for certified crop advisors to take, and it's like, oh, look at this one. The most precise component in a soil testing program is normally a sampling. Well, if you're paying, I just started, it says it's really challenging maybe to get a good representative sample. That is not it. So, or laboratory analysis or extrapolation, interpretation, recommendations. I'm just going to hit, I think, yes, it is B if you said that. Pat yourself on the back. Laboratory analysis. Okay, so that is the part I'm going to get into the laboratory. You've taken a good, hopefully someone's taken time, trouble, get in the cost to get a good representative sample, take it and get it to the lab. So now I'm going to take you what happens in the lab. This is where I could talk too much, so I'm going to stick to my notes and try to keep moving right along. So, all right. After samples are received, the first part of the analysis phase is the sample preparation. When we set up and handle samples in batches of 30 with 2 quality control samples within those 30 samples. The soil is air dried over 2 nights. As soon as the samples are set up in trays of 30, the office area can start entering the information sheets, which are then immediately observable online to local extension offices. After drying, the soil is broken up into the natural sand, silt, and clay-sized particles and sieved through a 2-millimeter mesh sieve. Once the soil is air-dried and sieved, subsamples are scooped for the next step. That dried me out right there. After sample preparation comes the extraction for the nutrient analysis. Now the Mehlich 1 extracting solution is added to now down to a 4 cubic centimeter scoop of prepared soil, and it's shaken, filtered, and transferred. So again, we've broken up, mixed it, and homogenized what we've gotten in, but now we're down to a very small amount of soil material representing maybe a lot of soil out in the field. So let's see, the chemical extracts are used to pull out plant available nutrients, or at least amounts that we can correlate the plant growth. Now, selection of the extracting solution depends on the reactions that control nutrient supply and availability in the soil. Different extracts are used for various and good reasons. However, one cannot directly compare resulting numbers from one extract to another extract. And that's the complicating factors for those who plan, right, nutrient management plans with soil test reports from different reports. So I'll be heading in that direction. How do you handle that? Okay, now at one time it took 3 different methods and instruments to report just 4 elements we got back. So now we use an ICP instrument to simultaneously measure all of the 9 elements that we're going to report. So this is just a closer look at sample extracts on an autosampler being fed into the plasma of the instrument. I'm not going to take time going into any of that. Go on an online tour, maybe spend 5 minutes, take an instrumental class, maybe you can spend an hour or 2 on this. But big, large ag and environmental labs will use an ICP instrument because it's multi-element, can do all of ours, even metal and non-metals, P and K, the big elements. You're not testing nitrogen, P and K, I mean, you want to know accurately down to low levels even. This is more accurate in low levels, like for phosphorus, so econometric I used to do that. Not as good, maybe in the lower levels, where the farmer's going to spend a lot on fertilizer, and on the high end, someone like Steph, a regulator, I mean, well, you got more phosphorus than you need for the plant growth. You don't have to worry about that. Phosphorus will be limiting, but can you put any more manures on these fields? So large linear range I'm getting to on this instrument. So great number cruncher, multi-element simultaneously. So it's only about a minute per sample, down reproducibly down a part per million level. So, that's how we can process hundreds of samples in a single day. All right. I'm letting myself get chatty because we had extra time, right? All right. pH analysis.
You're very good on time, so don't worry about it.
Yeah, well, that's why I let myself get a little more chatty. So, pH analysis, when we needed help from several student workers. I used to hire a bunch of students, and would disappear at spring break in March, our busiest month usually. Now, pH measurements use automated setup. One person, that's how I got less labor than I used to have. I'm automate as much as I can. One person can keep up to 4 pH probes operating at a time, and I can program in what I call a stable reading. I've had new workers. Now you gotta wait longer. Now you're waiting too long, and then they write it down, and then they leave or may go to class, and then, all right, was that a 5 or 6, that first number? Big difference, So in our lab now, the routine analysis, no resulting numbers ever have to be written down by hand or typed in later. The numbers just go from one computer to another. I think is more consistent and reproducible. All right. I'll take a breath here. I said 4 components soil testing. We've covered the first 2. So now into interpretation. So as the level of plant available nutrient in the soil decreases, so does the amount of plant grows. Makes sense. Until it levels off, though, eventually it will. And then perhaps even goes down. So adding more at some point, you spend money on that fertilizer, you're not going to get a return for the dollar. So it may actually go backwards. So we recommend fertilizer in the deficient or responsive area. Just going to say different terms, different words people using, and we recommend a low or insurance or maintenance or replacement fertilizer in the adequate area, so the gray zone. And low insurance, we may go up to the M plus, high end to medium, low end to high, because field variability. So you don't want that loss. And again, the phosphorus, if you're going to be growing there next year, didn't use all the phosphorus mainly because of a drought. Oh gosh, lots of times, let myself go off script and get chatty. They didn't soil test because I can't. Well, they don't have an excuse here. Farmers can get the routine test at no charge. So in state. But I've heard this going back maybe years, like, oh, I'm not sampling this year, low yields, I don't have the money. Well, that's exactly when you need to be soil testing. Soil testing is best for what, Courtney probably said that, right? What builds up in the soil. If you put phosphorus and it didn't get used, you invested, you've put that phosphorus in the bank. So you want to know, it's still there, confidence still there. I don't need to add more or less phosphorus fertilizer next year because it was a bad year the previous growing season. All right, now let's see. And we recommend no fertilizer when above adequate. Well, commercial vegetable crops, high-end cash crops, that's maybe an exception, but otherwise generally we don't. So, and eventually all crops, no, don't add anything more. Not for the plant and also environmental speaking usually. Okay, toxic levels can be reached mainly with micronutrients. Since I didn't give the talk, I'm confused, but yes, that was covered in the previous talk. So, all right. So, how's this all done? One needs a calibration curve. Otherwise, test results are worthless. I mean, we could do in the lab be as precise and reproducible as possible. It's worthless without good interpretation. There also, it gets, I don't go there, soil health and like, oh, these good tests. There's so many variabilities and a difference, interpretation difference of soil. It just gets, unless you have good interpretation, that's the tough thing. And that's part of the problem with mobility of nitrogen. Roy McGuire, Dr. McGuire, no, that's not tomorrow, it's afternoon. He may touch on that, part of the challenging part there. But here, each circle here represents an experimental field plot. So soils with different soil test levels are used, which results in different yields. Okay. The best fitting curve is then calculated. So eventually, the yield flattens out, yielding no more crop with increased amounts of nutrient, and a critical level is established where above this soil test level, there's no increase in plant yield. And interpretation categories such as low, medium, high, some labs may say sufficient, or different terms maybe, but they're assigned to the various ranges of test values. Now, so the grower samples then interpreted based on those assigned ranges, and that's sort of computerized. And let's see. Okay. Additional fertilizer response, or soil test calibration field studies are needed to provide recommended rates of fertilizers to apply. I mean, reproduce a study, but all different soils, especially this state, we're going from sandy coastal plains up here into mountain clay soils. It'd be good to do it on different soil types. Same for soil fertility research. Now, these recommended rates will vary depending on how productive a soil is considered to be. Getting into all that. Now, my lab does not test nitrogen. It's already been mentioned. Therefore, do a PSNT, pre-cytosine nitrogen test. Dr. McGuire, again, I think hits on that this afternoon. However, my lab does give a nitrogen recommendation. How? Well, it's based on the yield and the crop to be grown. And again, previous one, was that a legume? There's a nitrogen credit. That's how we do that. And only because you pretty much know if you're growing that crop, irrigating or not, on this soil, you're pretty much going to know what you're going to need in nitrogen. So, and then what are the nitrogen credits, and that's part of the PSNT. So, but nitrogen gets a lot more complex, and it will cost you a lot more in time and money and be less useful in the laboratory test, I'd say. So again, a soil test is best for nutrients that could build up in the soil. Note that no P and K is recommended at the VH, very high level here. So a low, especially a very low rating is critical. So medium ratings are in the gray zone. So, so a low rating means high probability of response from the plants to added fertilizer. So now here, potassium in the sandy soil is a source similar. We heard about sulfur. It can test low in the plow layer, but because a yield, but it may not cause, it could be a low soil test level, but it may not cause a reduction in yield due to accumulation in the subsoil. That's probably going to be in the coastal plain, the sandy soils, less CEC. Again, monovalent, the first talk, it's sodium, and then next potassium's next one to get bumped off an exchange site. But it could, like sulfur, could go down to a argillic horizon if it has that, or a clay horizon, and it could be where there's going to be more CEC. It could hold potassium. So a lot of that's knowing your soils and your field and field history. All right, take a breath. Let's see. Take a drink. What is needed to make a lime recommendation I'm going into? So for us, First, the crop to be grown, that sets the target pH, or where do you want to be. Next, the soil pH measurement tells you where you currently are. So the amount of exchangeable or residual acidity, which sets the buffering capacity of the soil, determines how much lime will be needed to get from where you are up to the target pH. Generally, the more clay and organic matter in the soil, the greater the soil's CEC, cation exchange capacity, CEC and exchangeable acidity. And again, greater the CEC, the greater acidity is going to be held, that aluminum and hydronium ion. So the soil, the water, pH. Now, in the lab, we talk about pH we determine to pH, what we're determining the pH and what's the solution. I mean, you do a water pH and do a buffer pH. On the report, it probably just says soil pH and buffer index. So we're not mentioning two pHs on the report. And if you're talking to somebody on the phone, they just see pH and they give you the wrong pH. So the soil water pH measures only the active acidity that's in the soil solution, and that's like what the plant roots see. That's what they're interacting with, the roots. When you add lime to the soil, it neutralizes this acidity in the solution here over on the right. So, however, frequently there's plenty of acidity in reserve that's bound to soil particles, and they're ready to replace what's been neutralized. Like they come off the bench and go out to the field like a football player. So it's like, well, you didn't really change the pH. So a buffer pH reading will directly measure the total acidity, all that acidity in there. So you sort of need to know that. So here is a simplified, oversimplified table of the lime recommendations. And note our Mehlich buffer index starts at 6.60. So, and then the more acidity, the more it drives down that pH. It's sort of a tug of war between two buffer solutions. So as the buffer index or pH goes down, the amount of acidity in the soil increases. Therefore, the amount of lime recommended, like here, if we want to go up to target pH is 6.2, it's going to go up as
How are you?
I'm good.
Buffer pH goes up. So now the lime amounts also increase as the target or desired pH goes up. You go from 5.2, 6.2 to 6.0 here, like the bottom line, you're going about 5 tons, 6.5, almost 8 tons per acre. So I mean that's all common sense, makes sense. So let's see. So Virginia Tech's lime recommendations are based on the following factors. First, the crop to be grown, that sets the desired pH. Next, the soil's current pH, followed by the buffer index or buffer pH. And then lastly, a credit for any lime applied in the last year and a half. And again, that's provided to the lab as the sample information. So the first two decide whether, if any, lime is needed for the desired crop to be grown. I mean, if current pH, the soil water pH, is higher than target pH, yeah, you're not going to want lime. That's where maybe a home garden, always adding wood ashes every year. A lot of it, they burn wood, burning stone, they plenty on there, adding it all the time. Too much of a good thing is not good. And you can get, again, micronutrient deficiencies, going back to the first talk. So, but if it's under the current pH is under the target pH, most agronomic crops, that's like 6.2 for us. So like, okay, well, how much lime do I need to be adding? So that we go, the third factor Virginia Tech uses, we go to the buffer, the Mehlich buffer solution to measure the buffering capacity of the soil. So this buffer is also being used by Penn State and NCDA, North Carolina Department of Ag. So it's got to be careful that different labs can't be that simple, right? Like different extracting solution for the nutrients. Different labs use different buffering solutions. So some are geared for higher CEC, lower CEC soils. Then they've changed for environmental reasons. But note that a lot of other buffer readings will be higher than the Mehlich buffer pH starting point. So if the buffer pH on the report is greater than 6.6, that's probably not going to be a Mehlich buffer value. I think I still get more into all this stuff. Let's see. So here's a buffer pH of 7.75. I mean, this is an old lab but it still makes its point. So so this lab is probably using at that time an Adams-Evans buffer solution. But I look at the soil pH by itself, 4.9. It's like, oh wow, you're going to have to be putting a lot of lime on that. Must be a lot of acidity. Not so fast. The buffer pH is 7.75. Like that's Adams-Evans buffer was like 8. That hasn't really made much of a dent in that. So I'm guessing no. Wait, hold on. You're probably not going to put on much lime on this to bring it up to target pH. And I hit on it later, but here's CEC. It's probably an estimation, 2.9. So in Virginia, if I get a CEC of 3 or less, I'm thinking East Coast sandy soil, so low buffering capacity. So that sort of backs up what this is, that you're really probably not going to be dumping a whole lot of lime on. Maybe you put a half a ton over there every year. Around here, clay soils in the mountain, you get maybe 2-3 tons per acre maybe you'll be having to put on for the same pH because of the total acidity. Here, I'm just saying the fourth factor is any last lime application appears on the report, which helps indicate whether a lime credit has subtracted from the buffer calculated amount. I was just verifying this yesterday, I guess, that the new reports will show that right on the recommended lime. It was this, but minus his lime credit, so you won't have to be going searching for that. So I may repeat going later. Let's drop down here. This is all the numbers. Soil pH. Another thing to do, again, soil pH buffer index. We don't, on our reports, we don't do 2 pHs. So you ask somebody and they give you the wrong pH. The other thing is report the water pH to 1 decimal place, the buffer to 2 decimal places. So if you ask for the soil pH and they give you, something 0.21, they're giving you the other pH. So all right, moving along. Let's see. On our reports, the lab test results are printed on 2 lines with most of the second line values being calculated from other measured numbers, and I've sort of highlighted those. So the reported CEC value is an estimated CEC because it is calculated by summing 4 numbers that have already been determined. And like we have an equation, we estimate the acidity from the buffer index or pH. So unless you are paying more in time and money, any lab reported CEC value is probably an estimated CEC. Yeah, I'm not going to get to that anymore. That'd be confusing. Let's see. For Virginia soils, I expect most estimated CEC values to be between 1 and 2 milliequivalents per 100 grams. Higher if a lot of organic matter has been added, or incorrectly higher if it's an estimate. If salts are high, or pH, the salts are high, or pH is alkaline, because you're going to be measuring like PK calcium that aren't coming from exchange sites, but that's what numbers we add together to get the CEC. So you can end up with a wrong estimate. So it is an estimate. It's a generally good estimate tool. Yeah, I've looked at those reports again. If it's 5 or something, a lot of organic matter to homeowners, but if it's like 3 or less, I know, okay, if I didn't know or you get an email, where are you in the state? It sort of may affect my answer. If it's less than 3, you're probably talking a very sandy, low CEC soil. So it holds less nutrients, less buffering capacity, things like that. Besides giving an indication of the soil's ability to retain some nutrients against leaching again, the estimated CEC provides a clue to relative amounts of clay in the soil. Since organic matter levels are usually fairly low, and since sand and silt particles have essentially no cation exchange capacity. We also report the percent saturation of the base cations to help catch any extreme imbalances, but don't go crazy with this. So, like balancing the soil, as in the basic cation saturation concept, as the approach of the soil should contain a certain percentage of each of the basic cations in order to be balanced. However, the basic cation saturation approach to soil testing has not stood up well under the evaluation by soil fertility researchers, and the evidence points to the continued use of the sufficiency level approach to soil testing, where the optimum soil test level of each nutrient is first determined through research, and that level is used as the base of the recommendation. Now, this is going back to very beginning, the first talk, law of the minimum, Dr. Levy, law of the minimum. We go, our concept is recommendations by a sufficiency level, not to nutrient balancing. Most times they do that, unless you have all this calibration for that specific field, a good chance you're going to maybe throw things out of whack, or you're going to spend more money on fertilizer than what we deem necessary. So now, all right, let me get a sip of water. This last part, getting where the rubber meets the road here for you guys, writing a nutrient management plan. To write one, the main numbers to pull off a Virginia Tech soil test report are the P and K, phosphorus potassium levels, and the lime recommendation. So I've circled them here. Let's see. Well, I'll probably cover what I was going to say. So, but now I'm going to cover soil test reports from several other labs. That's where it gets more complicated for you guys. I like to give you rule of thumbs, cheat sheets if I can. And heads up warning, different reports. First, be careful because labs will report values in these different forms and units. You have different extracts, different forms, different units. Now, generally in the lab, like it's more on the left, we're measuring elemental P and K levels, but there's different ways. Specific ion electrode, like a nitrate. We're measuring the nitrate part of, there's the cursor, of nitrogen. But you talk about a fertilizer label. What are they? No, you're not going to find it in these forms, but the oxide forms, the P2O5, the K2O, and just nitrogen. So the fertilizer labels are sort of just opposite of what you're sort of measuring in the lab. So if you had to convert it, elemental to phosphate oxide form, it's going to be a larger number. It should be. So you should be multiplying by a whole number greater than 1, because it's got twice the weight of phosphorus, the weight of 5 oxygens. Again, you're not going to probably find that chemically in that form in the fertilizer, but that's by law. That's the way you express it. So again, 2 potassium, so it's going to be something just barely 1.2 to get there. So to go the other way, I'd still rather deal with the whole numbers than fraction. So I remember 1.2. So multiply to get bigger. You're going to elemental single potassium divided to make it a smaller number. Okay, down here you got parts per million ppm and pounds per acre. Pounds per acre is double ppm because an acre ferrule slice is generally thought of about 2 million pounds of soil in acre. So an acre of soil down to plow depth. You generally thought it'd be parts per million. So essentially pounds per acre is parts per 2 million. ppm is parts per 1 million. So, okay, now it sounds makes sense. Double parts per 1 million, you get the parts per 2 million pounds per acre. Go to ppm, larger number, cut it in half to get to ppm. All right, again, there's these footnotes. I guess I put that down there. Nutrient management, or North America Handbook, page 163. So I still got references down there. So, okay. So if you're going to write, oh, wait, everything flipped here. So, results, if you're going to write a nutrient management plan in Virginia, then results from other labs must be converted to Virginia Tech values so that recommendations can be based on values recommendations. I'm not going to get into values because I think you get enough of that elsewhere. So how do you deal with the use of different extracts? Well, correlations have been made between extracts, and equations have been developed to convert results from other laboratories to Virginia Tech equivalent results. Use of my lab plus at least other 8 labs, well, I think it's a lot longer than that now, have been approved for use by DCR for nutrient management
16.
plans. Yeah.
16 labs.
Oh, 16. I figured it'd really a whole lot more. So
yes.
I didn't look there in a while, and I figured I'm not surprised it's double.
We went through a really big spurt over the past 2 or 3 years. We added 4 or 5 different ones, but they all have to be either Malic 1 or Malic 3, like Steve said.
Yeah, I could see that. Some have some lab and or they've asked for it because they go there because it's a water extract. Well, that's not going to extract much phosphorus, but maybe that's what they want so they can apply more manure to the fields. But that's not acceptable. So, because
they try.
My bottom line answer there, before you go writing a plan, or if you're sampling or something, is like before you go all that trouble, the bottom line is just take what's this report, whose lab is that, and sure, go to a current, maybe just got added and there's 17 labs now. You go to DCR's website and see what the current list is. Otherwise you're wasting your time. So that's the bottom line. I don't keep up with it. It's like, go check, because as I said, frequently, maybe every year, boom, there's a new lab now, so usually you'll get to know the main labs and don't need it. But yeah, you want to check it if you're not familiar with the lab. So, all right. So these conversions are for labs using the Malic 3 extract and are in the July of 2014 version of the Virginia Nutrient Management Standards and Criteria Handbook. Boom, our book, pages 41 and 42. So note that there are 2 equations. Yeah, this is for phosphorus. There are 2 equations for phosphorus for Malic 3. The one to use depends on the phosphorus soil test level. To give you a feel of where the breaking point is, 205 parts per million of Malic 3 elemental phosphorus is over 1.5 times as much what Virginia Tech starts calling very high. So it's up there agronomically speaking. You're at the point where it's not going to really make a difference. The plant's got enough phosphorus for the growing season. That's not going to hold back yields. But we have environmental questions. So you want to switch, if you go really high, to that second equation. Again, watch the units. Labs may change how they're reporting values too. So let me click the slide here on the bottom. If reported as P2O5, so not elemental, P2O5 oxide form in pounds per acre, then one must convert to elemental phosphorus and to ppm in order to use these equations. The equation is not using for what this maybe report provided, to use that up there, you got to make conversions to make sure you're plugging in the right numbers. Otherwise, totally different results. Meaning, what was I going to add? Oh, maybe just, it won't matter which one you convert first, but you got to do both of those conversions. So, all right. Now here are the equations for potassium, and you've got this. I'm not going to spend time on that. Now, this is an older lab, but an older report from Spectrum used to report P and K in units of pounds per acre, just to show you how things can change. Here that I noticed, it's like, oh, let me update our slides. And I got, oh, they changed the report, looks different. And they changed the reporting units. So if you use, okay, this report, they gave me this number, just plug it in. Make sure they haven't changed something on you. They don't let me know they've changed something. They're not going to let you know. So now, I say this, what's good now, I'm going to show you probably a bunch of other slides from other labs, just show you up how things could change up and be different, but at least now pretty much every lab's got a website and they show you an example report. So again, if you're dealing over the phone, you don't have the actual report in front of you, get numbers, maybe over the phone, you can go to the lab's website and, like to help make sure you're getting the right pH or the right number. They're giving you the right numbers off the form, So some things, give you a heads up. This is from Brookside Labs in Ohio. Now they, I think, only deal with consultants. So Brookside, last I know, offers at least 4 different buffers. I mean, they get samples from all over the world. So the vast majority of them are going to be, they used to use the S&P buffer, but they've switched for environmental reasons, the reagents in there, to the modified S&P or the Sakura buffer. And some, so yeah, I try to put cheat sheets or notes on here. If you see S&P buffer, if you see modified S&P, if you use Sakura buffer, you can treat them all the same. So again, what number you need to pull off here? Well, first I'll say, I think everyone's always said, Stefan's correct, that if a lab tells you to apply so much lime, you can just take that and run with that for the nutrient management plan. You don't have to worry about the pH.
Okay. It's much preferred to use the lab recommendations. You can use Nutman or the module if they don't give recommendations, but it's not as accurate.
Yeah. So that and say that wipes out all that. So, but some consultants here are told, like them, they don't ask for any buffer pH. So next thing, the report doesn't have one. But in this report, I've circled here. You got to go to the pH line. Okay, there's 2. There's a buffer. It's great. They say it's an S&P buffer on here. You know what you're dealing with. And then H2O, that's water, 1-to-1. That's like we do. Sometimes people do 1 and 2. That's why it gets tricky interpretation. These are different samples, but yeah, you want to use, yeah, you probably will want to add lime. Over here, probably not. Okay, that, how much, but you don't have to worry about it. A lot easier if they just give you a lime recommendation. Okay, but pull the right number off. Okay, phosphorus, where is that? That's an anion. So here, phosphorus category. All right, where's the number? Okay, there it is. Here's easily extractable. Where's the cursor? There. Easily extractable, you can equate with Malic 3. So mainly want to deal with Malic 1 or Malic 3. Okay, good. I don't see Malic 3. I see easily extractable. Okay, take that as Malic 3. All right, they're given 2 things here. Well, given our equations we had earlier, we don't want pounds per acre elemental phosphorus, or maybe no, as piezotyl oxide double. No, thank you. Save the conversion. I want ppm and elemental phosphorus. So you want that number. Just think, if you grab this number off of it and weren't careful and calculate, oh, I got to go to the second equation, and now I got to tell that grower, you can't apply any more manure to these fields. Or if I plugged in the appropriate smaller number, into equations, yes, you can still apply some manure onto that field. So it can really change things for a grower. Potassium, you need to pull off. That's a cation, exchangeable cations. Here's potassium again, in 2 units they give you. Well, I think that's why I assume I circled it on that equation. Some reason it said you had to plug in pounds per acre. So you want to use this number, not the ppm in that case. You plug in the wrong one here, you say, hey, you got to spend more money on potash fertilizer. It's like, you use that one. No, you don't. So, okay. This is just, well, an all one, yeah, A&L waypoint for years. But they on their first page, again, their phosphorus, potassium, pH was looking like that. Check their website. Main thing I'm trying to point out is that they often recommendations, at least these two, the test results were on one page, second page were the recommendations. And again, that's not a null value. I assume that's saying no lime. So they gave a recommendation, and you can run with that for the lime recommendation. And, you know, there was agroanalysis lab. I mean, here's Logan's lab, just to give you a feel how they you know, look different. There's agro lab. Okay, converting the conversions from the Waters lab in Georgia. Now they have in North Carolina, but in Georgia lab is using Melic 1, probably because the state lab that uses Melic 1. And the North Carolina is using Melic 3, and that's why probably the Waters lab in North Carolina is using Melic 3. The numbers for these two labs from Georgia to Virginia Tech are basically the same, because since here the conversion factors are essentially 1, because both labs are using the melic extract, so the same extract, reporting the nutrients in the elemental form and in the same units. It's then going from one report to the other. You got to worry about 3 things: what extract, what form it's reported in, and the units are reported in. Therefore, one can use the P and K numbers here as if they were on a Virginia Tech report, and just use them, just go with that if that's the case. So now here's a sample lab from, you see it, all right, hey, it's Waters lab. Okay, which is it, Melic 1, Melic 3? Upper right, it says it's from Georgia. Even better, test method, Melic 1. So, okay, good, I'm going with the Melic 1. So you can pretty much just use these numbers, P and K, as if they're coming from Virginia Tech. Now, they're not using our buffer, but recommendations, lime, yeah, but you don't have to sweat that because they give lime recommendations. So, but again, same headline, it's getting covered over, but you probably see it. What there? Waters lab, but 2 different methods, even for the same lab. So you can get that in private labs. Oh, okay. Good on time. Then talking about soil testing. The last part, going to go into land analysis, a lot shorter part. So we'll get to lunch. And so tissue testing, it's more commonly used as a to diagnose nutritional problems related to soil fertility and to monitor effectiveness or fertilizer practices on growing crops. Soil testing is more sort of preventive, you know, oh, do I need to stock up the plant's refrigerator, right? That analogy. Most of the time, tissue testing is probably, you know, well, it's got to be what's the plant's growing, and probably more troubleshooting. But I got pictures here like that's an apple tree, some fruit crop tree. You know, they may use it to fine tune their recommendations. But most people's probably, you know, agronomic crops out in the field are probably used for troubleshooting. And it's not a substitute for soil testing. It's most effective when used in conjunction with a regular soil testing program. Again, if something isn't getting into the plant, maybe it's not in the soil. So you want to use it in conjunction. Here's an interesting thing. The nitrogen management for wheat and barley can be partly based on a tissue test, and it's covered in DCR's nutrient management booklet, which is online, and it's mainly on page 73 until you revise it. So, sufficiency ranges, again, are developed in order to interpret a tissue test result, sort of like soil testing. If a result is below or above this range, then the nutrient content in the plant is either deemed sufficient or excessive or perhaps even toxic. A single sufficiency range is good, though, only for a specific plant, a certain part of the plant, and at a particular stage of that plant. So if you thought soil testing was troublesome, soil sampling, tissue testing, more of a pain. You have a lot more window of opportunity to soil test than you do tissue testing. And then some labs may break these categories down maybe as much as 5 different categories. So, and it's all interpretation and sort of getting together. You guys, sampling is important. Sampling is even more important. So you could, and make interpretation. So, again, there's a set of sampling protocols. So the results can be interpreted. Proper sampling requires that a specific plant part, like a particular leaf, be taken. So, yeah. Try to get instructions from the lab you're going to send the sample to. You don't do any tissue testing anymore. Long since here on campus, we do have a plant clinic for diseases, but for nutrient testing, tissue testing, you'd have to go to another lab. So, however, if you have no instructions are available, the general rule of thumb is to sample the upper, most recently mature leaves. At the bottom of the slide, I reference pages from an extension publication that gives sampling instructions by crop. A link to this handbook is again on my lab's website, which I should do a quick quiz again. What's that web address for the soil testing lab? It's soiltest.vt.edu. Shameless self-promotion, yes. So, recommended time to sample, usually just prior to beginning of the reproductive stage. General rule of thumbs I'm giving you. Okay, what you need to do, and this is what you don't want to be doing, the do nots. Do not collect diseased or dead plant material. Not really going to be representative again. Materials damaged by insects or mechanical injury. Again, not representative. Nor from a plant that has been under nutrient stress for an extended period of time. Yeah, it's not going to test well the tissue, the plant, if there's been a severe drought. It's in the soil, the nutrient, and you just can't take it up to tissue. Tissue is going to test deficient. If a nutrient deficiency is expected, especially during the marginal time for the sampling of the plant's growth, then ideally and practical, ideally collect samples from the bad areas and from the nearby good area. I know that's twice the sampling, twice the cost, but again, interpretation, and that's critical. And if it's not the right time, the right part of the plant, it could just be misleading. So it could be really good right on the field, right here, like, oh yeah, that one is a little bit worse than the other. That and something else may have thrown it over the edge. Okay, let's see. Now, if leaves are dusty, so actually we needed that rain. It was a pretty nice rain we got here over the weekend. But you get one of these down thunderstorms, maybe bring a lot of phosphorus deposit into the soil from the atmosphere, but it can knock up that soil onto, like the picture, soil materials actually on the leaf. So if it's dusty material on there, brush or wipe with a damp cloth to remove contaminants, or wash in a mild detergent and rinse in running water. So again, tissue testing can be a lot more time consuming than soil testing. So, you know, I'm not that much with tissue testing, but I mean, one thing I think, if you get tissue testing back that's just super extremely high in iron and aluminum, the result is that may be an indication that the tissue test was tested from the soil. You're not getting exorbitant levels of iron and aluminum in the tissue. It's because some soil material was on that tissue. So again, it'd be good to air dry tissue samples before shipment to the laboratory. Otherwise, the lab may receive degraded mush to test. Now, if you're sending it, well, I'm thinking a couple things. So that's probably more important than getting the soil dry. And, you know, and we do have a plant clinic here. You don't want to do it. You went out there trouble getting tissue tests. Think about, you know, you want to dry it. Otherwise, like the plant clinic, you get it, put it in something like Ziploc bag. Plant clinic gets out and it's mush. Guess what? They're probably going to tell you. They can't tell you anything from this. So, and tissue testing, we go, but certainly the plant clinic for disease and stuff can't tell you anything from this. So it'd be real important to get it air dried. Now no plants are growing now. I mean, we got a holiday weekend here coming up too. So let's say, okay, plants growing, early growth. Say we got now Juneteenth and we got a 4th of July holiday. Think, oh, I'm anxious for these results. So I just sampled these. I mailed them off even overnight or something. Wednesday, well, maybe it gets to campus mail. It doesn't get to the plant clinic. And then Friday, well, that's a holiday. 4th of July is on a Saturday. Holiday sits there, you know, earliest Monday they're getting it. So it's all these days and oops, it's mush by the time they got it. So try to time the shipment. You might want to remember too. Another bad thing we tell about people, like you get soil test reports, switching back to that real quick, a lot quicker now. Mail seems to be even worse now. You know, by electronic emails you get, or you're going to go on the news system. You're just going to go on and see your results online. You get an email, go on there, you get new results. And but you still got to get the samples to us. And we tell you, UPS and FedEx come straight in the lab. U.S. Mail, I don't know if I want to badmouth them, but goes to Greensboro now, out of state, then they come here, supposed to come to town every day. Do they? And then it goes to campus mail. Then it's got to get sorted. Then it's got to come here. Well, now UPS is going to be going directly to campus mail instead of coming straight in our lab. Right now, FedEx will be coming straight in our lab. So a lot of times there are issues with transportation, but enough on that. And more positive news, the new LIMS system. You log on, you get you just new reports there. You log on. I don't know if you can. The primary owner of those results, like the grower, they can switch the crop code. An agent couldn't do that in the past. The grower, like, oh, nutrient management plan. I want to switch, you know, crops now. So you know, it's too much lime. I'm too below to start alfalfa. I'm going to stick with this. They can change crop codes. They also can select multiple crops at once codes and see all the recommendations at once. So that is another change. All right, I'm going to stop there. I know we're going to time, but oh yeah, my last slide here. You may be here at the end of the morning still feeling like peppermint patty here, and your head's pulled a muscle. Your head can't absorb anymore. You've had enough, and you're ready for lunch. So Steph, give it back to you. Throw it back to you.
Thank you so much for all of that. And it gives me heart that if you guys could get online payment, then by gosh, someday I can too. Because it is a monumental task.
Yeah, it
Um,
was more than I thought. So
yeah, I've been fighting for like 4 years now, and I feel like nothing's happening. So maybe someday. But thank you so much, Steve and Courtney, for all of that information. Um, I know we mentioned a couple times the different labs that are up for use. That is always on our website. Please, like Steve was saying before, you start cracking on soil sampling, make sure that lab is there. Because I know a lot of people, especially farmers, are very interested in the Haney soil testing method, which we cannot do currently. So before you start going wild, make sure the lab is approved by us so we can put it in a plan. Like I've been saying, if you have any questions that you think of during lunch or in the middle of the night for Steve or Courtney or anybody over the next, well, yesterday and today, let me know. We will get those questions answered. We have about an extra 20 minutes. It's pretty nice outside, so I'd say enjoy the extra long lunch, and then be back here around 1 so we can get started off with Dr. McGuire this afternoon talking about nitrogen and phosphorus cycling, manure, PSNTs, and all that excitement. I'll leave this up and running again, so if you think of anything, put it in the chat box. Feel free to leave and come back. If there are any other questions, let me know. Otherwise, thank you, Steve and Courtney.
yeah,
Hope you have a great rest of your day, and I'll see everyone after lunch.
yeah, simple today. Don't wait to March. Thursday
Yes.
here we won't get above. We're breaking 50 here in Blacksburg today. Thursday we won't get
Whoa.
above freezing. We will not, and winds go back to like 10 to 20 miles per hour. I will
Yeah,
not
back to
be out.
winter.
No one will be out soil sampling that day here around
Not
here.
there anyway. It's still pretty nice down here in the coastal plains. So send it in now while you still can before the chaos starts.
Right. All right. Adios. I'll see you. Bye.
All right. Bye, guys. Thanks, everybody. See you back in an hour and 20.